More density problems. Problem number 2. And in this problem, you have a swimming pool. It measures 9 feet long. So the length of the pool equals 9.0 meters is what I should have said, not feet, by 3.5 meters wide. So the width of the pool is equal to 3.5 meters. And it's 1.75 meters deep. So I'm going to just call that the height is 1.75 meters. Now, looking at this one, it says what mass of water, so we're looking for mass, and it wants this in metric tons. So the first thing we're going to have to do is we're going to have to find kilograms, because it actually gives us that 1 metric ton is equal to 1,000 kilograms. All right, so we can do that conversion at the very end because we have this nice thing with an equal sign in it, right? So we can make a conversion fraction. And wants to know what mass of water in metric tons does a pool contain when it's filled. And the density of water, in this case, is 0.997 grams per centimeter cubed. All right, now we know the equation. We know that mass is going to be equal to density times volume in this case. So the first thing we really need to do is find the volume. All right, so when we go to find volume, volume is equal to length times width times height, which for us is going to be, our length is 9.0 meters times our width, which was 3.5 meters, times our height, which was 1.75 meters. Now when I multiply these together, I'm going to have to keep it to two significant figures. And multiplying that together, I get 55 meters cubed. So that's my volume. But if you look now, mass equals density times volume, but my density is given in grams per centimeter cubed. The easiest thing for me to convert here, if I have a volume that's equal to 55 meters cubed, I'm just going to go ahead and convert that to centimeters cubed. And the way I do that is that I take 55 meters cubed, make that a fraction over 1, multiply that by, I want meters in the bottom, centimeters in the top. Now that only takes care of one of the meters, because this meters cubed is really meters times meters times meters. So I have to do this 3 times. Centimeters, meters, one more conversion fraction, meters, centimeters. And now I fill in the numbers. 1 meter is exactly equal to 100 centimeters. 1 meter is exactly equal to 100 centimeters. And 1 meter is exactly equal to 100 centimeters. And when I multiply that out, I get that the volume is equal to, we're looking at 5.5 times 10 to the 7th centimeters cubed is how I would write that, just to save space. Once again, there will be 6 zeros after. There will be 55 with 6 zeros after it. And that would be in centimeters cubed. So now I can go ahead and multiply. So my mass will be equal to my density, which is 0.997 grams per centimeter cubed, times my 5.5 times 10 to the 7th centimeters cubed. Notice, the reason I did this, centimeters cubed cancel out. Leave me with grams. And when you multiply this out and you take it to 2 sig figs once again, you get 5.5 times 10 to the 7th, and that's actually grams. All right? So at this point here, we need to convert to kilograms. So I have start out with 5.5 times 10 to the 7th grams. That's what I know. And I want to convert to kilograms times, so that means I want grams on the bottom kilograms on top. And I know for every 1 kilogram, by definition, there is 1,000 grams. And when I multiply this out, I get 55,000 kilograms. So I need 55,000 kilograms of water. It's not what it asks. It asks for it in metric tons. So the last thing I'm going to do, let me draw a little line in here, is I'm going to convert to metric tons. Metric tons. And to do that, I take my 55,000 kilograms, put it over 1, and what the expression gave me up top is that I want kilograms in the bottom, and I want metric tons in the top. That gets rid of kilograms. And I know for every 1 metric ton, there's 1,000 kilograms. So I go ahead and multiply that out, and I get 55 metric tons. And notice how I carried through all the units so that all the units canceled out and agreed when they canceled out. All right?